Okay. All right, so we're talking today about async or asynchronous JavaScript, which is kind of one of the buzzwords around JavaScript. Hang on, my focus is gone. All right, so here are all the buzzwords we're talking about. Hopefully by the end, these will have meaning if they don't already. Basically, async, non-blocking, event loop, single process, single-threaded, events, callbacks, promises, async await, sync, blocking, race conditions, callback hell, and the then catch. If you guys have ever seen that. Okay. So before we do that, let's just look at when you first start off in JavaScript, some common noob mistakes. You kind of see they're kind of funny, right? All right. Here we go. So this one right here. Here is a simple loop kind of thing, right? Inside the loop, we're setting a timeout, which is initiating an asynchronous action. And let's see, can you see my mouse up there? Yeah, okay. So as we go through from 0 to 4, right, we're creating a new timeout. I'm recording, I hope, yeah. That after that timeout, you get a console.log I, whatever the value of I is, right? So just, you know, first time JavaScript, you come here, you think, what do you think this is going to log out? Well, yeah. It ends up logging out a bunch of 5s, right? But people would commonly think, hey, this is going to log out 0, 1, 2, 3, 4. It's actually a bunch of 4. So we can take a look and see. No, it's 5s I like. Can you see? Down here? Why is it doing this? Anyone want to explain real briefly why does it work this way? Why does JavaScript do this?
So it's printing out I at the time it gets to that console log, which since it's asynchronous, you can't guarantee when it's going to get to that console log. So
even right here, the timeout we're setting is small, right? It's like what, like 1 millisecond or something? By the time 1 millisecond has happened, it's long past all those I's have plussed up as high as they're going to go, right? So yeah, what he said was by the time this works right here, the value of I has already incremented up, right? And so that goes so fast, even that this timeout is only for 1 millisecond, that it's kind of it's run away from you. All right, here's one of the mistakes. Let's see. And then another one. All right, so here is another common issue. We need access to some data that we're going to use throughout our app, right? And here it's called my data. And in this particular case, we're getting this data from a file. This is node code, right? We're reading from file.json. You're looking right here. When that's done, what we're doing is we're assigning it, my data that we declared up here, we're assigning it when it's done, right? And we do a whole bunch of other stuff down here, whatever that may be. It could be relatively fast, or it could take a while. And then later on in our app, we actually need the value of that. So if you're to run this as is, what's going to happen when you console.log? So is there yeah, undefined. Is there a chance that it may work? What would make it might work?
Very small.
What's that?
Really small file.
A small file maybe, perhaps, yeah. Or right here, maybe this stuff what you're doing in here takes enough time, but by the time it gets through all this, hey look, that this has actually been populated. This is a race condition, right? All right, so hopefully this is not new. So let's talk about why JavaScript works this way. And the answer really is Async I, the topic of this presentation. So what is that, right? So we're just going to draw a really bad analogy. Okay, so let's pretend we're the mail system, right? And this mail truck right here represents basically your CPU, whether it's threads or whatever. Just a overgeneralization for CPU processing, okay? And we'll say the act of you going out, grabbing the mail, going back to your house, reading the mail, paying your bills, going back out to the mailbox and putting it in there. That's our I/O. That's our input-output. Okay? So let's pretend we're creating a mail system. And this is called the blocking post system, right? And it's the worst one ever. So here's your neighborhood. The mail comes, right? The truck comes to your box. Truck sits there and waits for you. You come out to the mail. You take your mail back to your house. You pay your bills. Truck's still waiting, just idle, right? Just waiting for you. And the truck moves on to the neighbor. Same thing happens. Truck's still waiting. Neighbor pays bills. Truck goes on to the next house, and so on and so forth. Okay. So, I mean, obviously this is silly, but what's wrong with this?
He'll never finish.
He'll never finish. Okay. It's synchronous.
The mail dance time's wasted a lot.
There's a lot of wasted resources, right? So it's inefficient. Spends most of his time waiting. Nothing else happens during I/O while the person's running back and forth. They're just waiting. And people are slow, or what if they're not home, right? That could just be sitting there for who knows how long. Okay. So let's create a new. That one didn't work. So we're going to create the threaded USPS, right? This is the sledgehammer versus fly approach. Okay. So here is your neighborhood, right? Now, instead of there being one truck, there's all the trucks, right? Trucks pull up. Everyone grabs their mail. It doesn't have to be synchronous. Like you don't have to grab at the same time, right? But like I said, this is just silly. All right, they read their mail, pay their bills, blah, 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 right? Makes sense? So what's wrong with potentially this approach?
You need a lot of mail trucks.
A lot of mail trucks? Anything else?
Overkill.
Overkill?
Trucks are still spending most of their time waiting.
The trucks are still waiting? Okay. So yeah, you need one truck per person, or you can maybe work out this pool system kind of thing, right? But essentially one truck per person. Trucks aren't free. It costs money to have a truck and to run a truck and to pay a truck driver and all that kind of stuff. And they still spend most of their time as idle. And it may not be the best use of the truck, sitting there idle, waiting. And the problem is that the truck's not the bottleneck in this situation. It's the people, right? It's the actual process of going and getting your mail and going back and this kind of thing, right? All right, so let's talk about the real life UPS and how it works. Your neighborhood, the truck comes and drops off mail. Truck goes on to the neighbor. The truck just keeps on trucking. And time passes and people get mail. And they read their mail. Some pay their bills and they put their flag up saying, hey, I got something for you, right? And then the truck returns the next day and it kind of repeats the process. It grabs new instructions if there's a flag up kind of thing. Or it just gives new instructions, that kind of thing. So let's talk about what's right about this.
Decouples the truck process with the mail process.
Okay.
The whole process.
What would be wrong with this?
Sometimes you just miss the mailman.
All right.
If you pay your bill real fast.
I mean, you pay your bills real fast, then basically your mail is just going to sit in your box for a day, right? Okay. All right. So what's right? The trucks aren't limited to the speed of humans, right? The bottleneck here is the humans, not the truck. And as far as the truck's concerned, it's the best use of the truck resource. It just follows along, does its thing, moves on, comes back. And then people can procrastinate. They can pay right away. If they need it right away, then they probably need to go do something else, like pay online or whatever. Okay. So basically the CPU and the I/O, they work in async, right? So let's talk about async I/O. In computer science, async I/O or non-blocking I/O is a form of input-output processing that allows other processes to continue before the transmission is finished. So just like the neighbors let the truck move on, right, while they read or open and read and pay their bills. It allows the truck to move on. The opposite of that would be asynchronous or blocking, right? And that's when they start an action and then they wait for it to complete. And such an approach would block the progress of a program while the communication is in progress essentially leaving system resources idle, right? The truck. So that at some point in time, depending on what your app is doing, you may reach a point where the I/O to processing ratio kind of intersects and goes up, let's just say, that your CPU is going to spend most of its time idle waiting for I/O. So if you have a heavy I/O app, right, then this model, an event loop model would make more sense than a threaded or, I don't know when a blocking one really makes sense, but okay. And the issue with that is I/O operations on a computer are extremely slow compared to processing power. And that is because I/O typically incorporates mechanical devices or physical devices of some sort that must physically move, such as a hard drive seeking to track, to read and write. And this is often orders of magnitude slower than switching of electronic current, like what happens in your CPU. So for example, during a disk operation that takes 10 milliseconds to perform, a processor clocked at 1 gigahertz could have performed 10 million instructions. So a little faster. And that's just assuming all the thing is accessing is right there on that box. But oftentimes, with web apps, you're actually going on the wire to a machine that then is accessing its drive back here, right? So the CPU is pretty much to never the bottleneck for web apps. Is that fair? Yeah? And I/O is the bottleneck, right? So in an app where you're dealing with high levels of I/O, an event loop, an asynchronous type of way of doing things makes sense, right? It's the most efficient use of resources. Okay. So in that silly analogy, the truck route is the event loop, right? So the act of the truck going around and around and around every day, except the loop's much faster than once a day. Okay. And this is way more knowledge than you'll ever need to know about the event loop. But per MDN, this is the gist of how it would work. It's just a message, it's a message queue of things, instructions to do. It just keeps going back and processing them as they come in. And if there's nothing there, it sits waiting for new ones to come. That's your main process, your main thread. That's what it's doing. So like I said, you as a web app developer, you typically don't really ever have to worry about the event loop. It's not something you have to really interact with in a way that you could even know. You don't even have to know its name, right? A high level understanding of kind of what's happening is sufficient. Just that silly analogy. Because you deal with it indirectly. Okay? So then how do you make your I/O operations asynchronous? And really you don't asterisk, right? They are already built into the environment and you just leverage them. So in the browser they have some async stuff, and on the node there are other kind of built-in things there. We'll talk about that. So in the browser here's a small list of things that deal with asynchronous I/O. It's Ajax or XHR, and then its new thing that is out, fetch, its replacement potentially. IndexedDB, CSS3 animations have some event hooks. Workers geolocation is a asynchronous API. It's dealing with all these things. Really, if the operation requires leaving CPU memory space to go somewhere else, that's pretty much an async operation. So on Node, there's quite a bit more. Core modules, they have the file system API, HTTP, net, there's just a number of them. It's kind of built around this idea that, hey, you're putting this in a place where I/O is going to far exceed processing. So let's build this platform to handle I/O, right? It's single-threaded, or one process, it's kind of single-threaded. It's not exactly true, but the idea is your main thread is that loop, and you don't handle any sort of, you don't worry about the magic that kind of happens, right? All right. So if you don't write async operations, then how do you async? I mean, how do you make sure what you're doing is asynchronous? And it really is easy. You just don't block the main process. And oftentimes, you kind of have to go out of your way. right? So like on the nodes, like the FS module has, by default, asynchronous methods for reading a file and things like that. They also have synchronous counterparts. If for some reason you wanted to block while that's happening, you could use the fs.readFileSync, and that will basically block anything else from happening while that 10 milliseconds or whatever is going on. Otherwise, you really just interact with Async I/O with the APIs, the platform that you're on supplies. Okay. So events. This is seems to be kind of the most primitive idea of asynchronous. It's when X happens, you do Y, right? So callbacks. This is basically, hey, you go do X, and then when you're done, do this Y, right? So this is kind of like you're triggering something, some asynchronous action to happen, and then you're telling it when you're done doing this, do this next. Okay, Y is typically a function you're going to pass in, right? So then you have this promises, which is built into ES6 now, right? And what that basically does is say, hey, give me promise P that you're going to do X, okay? So we'll kind of discuss the little differences there, right? And then in ES7, you have this async await, and it's kind of like promises without the funky syntax that people don't like, okay? And it's really, the first three are kind of like, they're more like primitive types, I guess, if you want to look at them that way, that are built into the platform. The last one is more syntactical. They still deal with promises under the hood. And there are other ways to deal with these asynchronicity. But these are the ones that are, usually those are built off these. These are kind of like the core things under the hood, okay? So let's take a look. All right, events. This is, this is pretty conceptually simple. When X happens, do Y, right? And they're nice because they're fast and they're decoupled. You kind of react to things that are happening, right? So you can kind of build this really complex set of events that happen based on reacting to events. You can build a really cool decoupled system that is very expandable and nice, that you can add at any time and remove, because really they're just listening and responding to events, right? So some of the cons of this is that you have some of those things have to be triggered, right? And that triggering code to initiate something can be verbose and not super reusable. And I'll show you an example in a minute. And then orchestration of events, async events, is hard, verbose, and maybe not reusable. The idea is I have a sequence of 5 things I need to do, right? The first one is the asynchronous operation. The second one is an asynchronous operation that depends on the data from the first one. The third one depends on the data from the second one, and vice versa, right? So you're sitting there, you have this chain of asynchronous things that need to happen in a particular order before you can move forward, okay? So here is a example of making currently making an AJAX request. Just raw JavaScript, no abstraction whatsoever. This is great if on your particular app you make exactly one AJAX call. This is great, okay? I'm sure that happens a lot. You create a new request, right? You open a request. You add listeners to events, like this request is going to send an event and say, hey, I've loaded, I'm done. You say, hey, when you're done with this, here's a function that you need to do next, right? In this case, we're making sure when it's loaded, that the request status, the HTTP code coming back is between 200 and 400 essentially. If it is, we're going to parse that data as JSON, right? On error, we're not really doing anything. I don't know, maybe not the most friendly thing. And then we're sending it off. Is this questions about this? Does this make sense? We good? We not good? Okay. All right, so that's nice. You can see how the key here is right there. This is hard-coded in, right? It's my API. What if I wanted to go to your API or his API or whatever? I have to rewrite all these things again, or I need to abstract away this into something, okay? So let's talk about callbacks, which is kind of abstraction away from events a little bit, okay? This is, hey, do X, and then when you're done, do Y, right? Does that make sense? We good? Okay. Here are the pros of callbacks. That the triggering code is more reusable. It's still fast and it's still pretty decoupled, right? It's hard to orchestrate, and when you have a whole bunch of them in a row, it can lead to callback hell. That's the pyramid of doom, or just an ever nested things of operations that you have to try to mentally keep track of. There are ways to help with that, but that's kind of the downfall there. Also, another con, you have to know what's next, right, before you can do this. I mean, you can't just say, hey, go do this, and I'm going to need your value eventually. I mean, you actually have to know what's next. Sometimes you don't know. Maybe you just want to preload information. So where do you find callbacks? Natively geolocation in the browser. That's a callback-based interface for these asynchronous things. You're going to find them as a wrapper around events, like add event listener, right? And in Node, most of the core APIs are callback-based. So any fs.read or http.get or all that kind of stuff, it's a callback-based API. So here's an example of this in the browser. I think everyone's probably done this at least once, right? You're adding a callback. In this case, it's a function that will log out the event details whenever someone clicks. Does that make sense? So right here, this is a function that you're passing in as a second parameter to add event listener. First one is the event. So hey, when I click, do this action. In this case, it's just logging the event details, right? This is in the browser what geolocation looks like. Very, very long. So right, navigator.geolocation.getCurrentPosition is a method in which you pass in a callback function. This particular function is called do something with position. And down there, you're looking at the function, all it's doing is logging the position. Right? So here is a native built-in callback interface for async. We good? Yeah? All right. Here's a Node example. We kind of saw something similar on how not to do things, but basically the same idea. Their core stuff is very much callback based. This is a read file, we're telling the file name, the encoding, which is optional, and then a callback function is right here. The Node signature is typically function error data. If there is an error, you do one thing. If error is anything other than null, you do something. Otherwise, you do something with the data. In this case, we're going to do something with json.parseData, right? Okay. So here's just a kind of a silly little exercise we're gonna do here. We're gonna take this code from our event-based stuff, right? We want to make this reusable. Okay. So we want to take this. This was the problem that we had. We had that. It's not reusable. We'd have to write all this code for every single one, right? We want to create a function that looks more like this. We're going to say, hey, request JSON. We're going to pass in what we want. And then we're going to also pass in a callback. So we're going to create this wrapper around a native event. Okay? And we're going to live code, so I'm sure this will go great. All right. So down here, we see to do, make this work. All right. Get JSON, passing in the URL. Here's the function, callback, right? If not error, we're just going to log out the data. Okay, so we need to transform this up here into a callback-based API. So feel free to tell me how to do it, or if you don't, I'll just do it. Anyone?
Make a JSON.
All right, make a JSON. We're just going to wrap all this in there, is that right? What? You're so smart, Corey. All right, it looks like we need to accept 2 arguments in here, right? The URL and essentially one callback to handle both errors and success, right? So this one's easy, URL, and we'll just call this one callback.
You need to go to line 1.
Oh yeah, whatever. Thanks, Bruce. That's what I meant. All right. All right, so that's good. URL, that's easy. We just replace this, right? Now what? So let's talk about errors.
Grab your request.unload and your request on error and your callback.
Okay, we'll do the error one here. This one's easy, right? We'll just do what we expect. If there's any error whatsoever, all we need to do is call our callback like this with anything other than null as its first parameter. You can say I'm an error. All right, that's going to trigger an error of some sort. Okay, so there's that one error. However, that's like network error, right? That's hardware error, like it times out or something, right? It's not 404 error. We want to do something when there's a 404. So we're going to kind of do something similar here, right? We're going to say callback, and in this case, we're just going to say bad response, right? All right, so we're good. We've handled the error case. Now in here, we're going to say, okay, well, this is the successful case. We're going to call back. We're going to say, oh, this isn't an error, right? And here's the data that came back. Hey, look. Over here it works. Good? That makes sense? Yeah? Any questions, comments? All right, moving on.
Pretty amazing, Joe.
Yeah, right. Okay. And there's the answer. Same thing that we pretty much just did, right? All right, so let's move on to promises, right? Promises have a little bit different workings, right? This is based, instead of, hey, go do this, then do that, this is, hey, just promise me, give me a promise, something I can have that you're going to do X. I'm not telling you what I'm doing next. Just promise me. Give me a promise, a thing you're exchanging, a future value, essentially, if you want to look at it that way. Right? And the pros of that is the responsibility of what to do next is shifted from the thing that is asynchronous to the thing that needs the asynchronous value, which is kind of nice, right? In some cases. The cool thing about that is now you can pass around promises as values, as arguments, as essentially that you treat them as future values, right? So you can't really do that. That's more difficult to do with events and callbacks, the idea of passing around the value. You actually have to restructure your code to chain together a bunch of callbacks or to create this event map where when this happens, it gets this, then it broadcasts that, then kind of thing. It's a little more verbose code and a little more difficult to do. So you pass them around. This makes chaining, especially chaining of asynchronous things, much easier. So when you have that situation where you're doing 5 things and all 5 are asynchronous, but 2 depends on 1 and 3 on 2 and whatnot, this provides a little easier method of doing that, okay? Where can you find promises? Well, promises are ES6. It's implemented in most browsers. You can polyfill where it's not. Some native APIs out in the browser, like Fetch, which is the Ajax replacement, I guess. It is a promise-based API. It returns promises. You could essentially transform events or callbacks now from an event and callback API to a promise one. And then on Node, I don't know if you find many of it in the core modules, but there are a ton of third-party modules out there basically have converted at some level the callback or an event-based API into a promise one. Please feel free to interject anytime.
One problem that I have with promises, though, is that you can't cancel it. That becomes a way bigger problem than it seems like.
Canceling, so that's another con up here. It can kind of swallow your errors, too, if you're not careful. They have this funky API. That's the .then, the .then, the .then, .then, .catch, right? Some people don't like that. So it looks a little funny. You can't cancel. You can't make them final, right? That was something that people wanted in the spec, was to make something final. You can't attach any more things to it. So here's an example of using fetch in the browser, right? Fetch is a promise-based API where you say, hey, fetch this. You can pass in a string, which will perform a GET request, or you can essentially pass in a configuration that will allow you to have more advanced options, like change the method or handle core stuff differently. Essentially, you pass that in. It returns a promise. That promise, what the value, a promise is, you can think of a promise as just a wrapper around a value that's either there now, will be there, or something bad is going to happen and it will never be there.
How does that syntax work on line 2? What's that attached to?
This?
Oh, is it just a? Is that supposed to
Oh, right here I do have an extra. This is bad, and this is bad.
So it's like inside a function.
Yeah, I think I refactored without doing things. So there shouldn't be. Thank you. Let's see.
Is that just supposed to be right on the dot fetch?
Yeah, this is me just messing up.
Okay. Oh, you're fine. I don't know. I don't know promises. You're fine.
It should look like. You wouldn't have this.
Okay.
You wouldn't have that. My bad. That's what happens when you finish editing like 5 minutes before this. Okay. Besides that, right, what happens here is it's going out, it's getting a promise. That promise wraps up. A promise is just a wrapper or container around a value. That value is either there, it's going to be there, it'll never be there. So a promise basically has 3 states, right? What happens is when that value is there or when it gets there, right? It'll basically then it'll go through these series of thens. You can think that's the way how you chain asynchronous things. So when this happens successfully, right? After that's done, it's going to go here and do this. And after that's done, it's going to go here and do this. And if anywhere along the way that failed, we're going to just catch that error and handle it, right? And all these arguments to the then and the catch are just functions. The functions look like this.
So, can I ask another question?
Mm-hmm.
So is the return from one function is what's passed into the
Exactly.
function of the next then?
Right. So if you need to pass, yep, exactly. So that's awesome when you need to transform, right? So, and you have a bunch of asynchronous stuff. And one thing feeds into the next thing as its input to output, right? So, yep, if the fact that I'm returning a response here, that means this to JSON one is getting whatever I return here, right? That's a good question. What's up?
You can think of it like a stream in a sense. Each then returns a new promise, which you can then offload, so that the resolution of that new promise will be what that then returns.
So in here, although we're not returning. Yep. Anyway, so if you notice here, we're just returning a response. The promise API automatically wraps this into a promise. So the to.json is still kind of operating under the sense of a promise. So if I returned here another promise, another fetch, the next thing in the line is going to wait until that next fetch happens before it goes on. So you can actually, that's how you're able to orchestrate that series of asynchronous events. Okay. Am I going too fast, too slow, just right?
Question.
Yep.
What happens if in your ensure OK function you can return a promise not reject there? Walk us through how it doesn't fire the second then and goes right to the catch method there.
Because the fact that it's returning a new promise regardless, it's just built into the magic of promises. So the state of a promise is just a container, right? I'm pending, meaning I'm going to have a future value. I'm resolved, I have a value. Or something bad happened and this will never resolve. It's a rejected or a broken promise, right? And so what happens is when the next thing, it's working on, if it sees a broken or a rejected promise, it just gets skipped.
So internally, the promise maintains a a list of thens and a list of catches. And so as soon as a promise is rejected, it begins executing the catches. However, if one of those catches returns a new promise that then resolves, it kicks back to where it left off in the then.
So right here, because I'm returning, this is basically what I'm doing right here, is I'm returning a rejected promise. Because the fact that the status of this promise containing this value is rejected, it's going to go straight to the nearest catch, right? Which in this case is right here. This is how promises can eat your errors. If anytime you say a then, just add a catch. You'll save yourself trouble, right? Not one catch per then. But I can return a promise that has a bunch of thens attached, and then attach more thens, and you can kind of pass them around, so you have this like decision tree of things to do. Anytime you type at least one then anywhere, you probably want to make sure there's a catch that at the very least logs something out, so that when errors happen, you're not trying to figure out where the error went. If that makes sense.
If you had some gnarly sequence of events, maybe I shouldn't use those words exactly, but could you do some thens and then a catch and then some more thens and then a catch, and those would be relevant sequentially to each other?
It'll find the first catch. So you could do some sort of promise, dot then, dot catch, dot then, dot catch, dot then, dot catch, dot then, dot catch, right? And so it'll find the next catch. And so your catches themselves, if they return a promise that's not broken, it'll actually just go on to the next then.
So if they somehow recovered from that error, then they could.
Yep. If they return a resolved promise, then all the remaining thens attached will fire. Good question. I saw it on. Yeah.
On your last callback in to JSON, where is that returned? What receives?
What receives this? In this case, this is just a fulfilled promise with a value, not attached to anything. So here I would probably want to, it's a good question. Right now, if this runs successfully, now we just have a promise sitting there doing nothing. It's resolved, it has a value. That value is JSON, but there's no next action associated with it, right? So if I wanted, in this case, I would create another thing here, right after that, another then, that maybe was just console.log, that logs the incoming value. That's a good question. It's just sitting right now. If this runs successfully, it's not doing anything when it's done.
Could you just assign that as a value, saying var data equals fetch my API dot then?
Exactly. That's how you end up passing future values around as values, right? So now you have an in-memory reference to this future value that you can then pass around that variable to other functions. And as long as they are treating those other functions, treating those parameters as promises, you're essentially you've kind of created a capsule around a future value. Yep, that's really the big perk around promises, is the idea that you can treat future values as current values. Like you can store them in memory references, you can pass them as arguments, all sorts of things. Any more questions?
So you can give the fetch more parameters if you want to do it.
Yes. Yeah, the things that you can do in there, like change your method, you can change HTTP headers, you can change whether or not it obeys CORS rules, all sorts of things. So
Sounds really similar to just a promise chain.
it is, yeah. The API literally returns a promise. If you try to do a typing on the thing returned back, it would be a promise. So this right here, this literally, the result of that is a promise.
You just get the keyword fetch.
Yep. This basically, here's a function I've created, a wrapper around some internal things. What it returns is literally a promise. And we'll write something here in a second. We good here though?
I don't know what promise, is that if I have multiple promises and then I'm passing around, how do I know which promise I'm rejecting in that promise?
Right here? So this is just rejecting a value, right? You think about every then, you can think of it as unwrapping a promise. It's getting to the value of that.
I don't know which one I'm,
Because of this.
it's just whatever's in that response.
Whatever comes in is a promised wrapped value. So response all the way through here are promise wrapped values. And they could be fulfilled. Like in this case here, the incoming one is a fulfilled promise, right? We're good. It's successful. But we're saying, okay, this has a particular API. All this response.OK does is it makes sure that you have an acceptable HTTP response code, that it's 200 through 400, or I don't remember exactly what it does. So that's technically a successful action, right? It successfully went out and grabbed something. That something maybe not what we want it to be, though, right? We want a 200. We don't want a 404, right? So we're saying, oh, hey, yes, this actually transmitted across the network correctly. We got the data we needed, but it's not what we want, right? So we're going to reject. We're just going to reject this so processing doesn't keep going. So we don't try to essentially parse non-JSON, right? So we're saying, okay, this incoming value, it's a fulfilled promise, is successful. We're going to take that and we're going to look at it. Okay, that value is not exactly what we want. We're going to send along the way a rejected promise containing exactly the same thing that came in, right? Because what we're doing is we're sending along response. We didn't mutate it at all, right? We're just saying the container around it, something bad happened, right? And we could put a string in here and just say, oh, bad, and that would work too. But just the next thing in the line, we see, oh, this is a broken or a rejected promise. Good? So, okay, here's another exercise. Same thing, we want to make this work, right? This is very similar to last time, except we did it with the callback, right? We want to wrap this native event-based API into a promise so that we can move forward with things, right, without waiting, or we want to pass that around, right? So first thing we need to do is, again, we need to create a function, right? And it is named getJSON. And it takes a URL, and that's it, right? Now all it requires is a URL. You don't need to pass in the callback. So the responsibility has now been shifted from the thing getting to the thing needing, right? Where it kind of logically belongs, right? And we're going to just take all this action here. And we're going to wrap it. Okay, so we have all this. All right, so our API here, based on just signature, we can see, okay, it takes a string, a URL representation, and what it returns is a promise, okay? So we've got taking a string, and right now it's not returning anything, right? That's why we're getting this error down here. So we need to return a promise, and we do that by saying return new promise. And this takes a function that says, this is how you resolve it, this is how you reject it. Okay, and then we have this body code that we just take all of this. So now you see how we're creating this cool like container around an action with a potential value, right? So now we have this new promise where all we've done is encapsulated that action that at some point in time eventually leads to a value. And we're just wrapping it and we're just returning that wrapper. This is kind of what makes it cool, it makes them portable, right? Okay, and so the API of a new promise is when you want to resolve the promise, you invoke resolve with the data that you want it to say, this is my data moving forward. If you want to break or you want to reject the promise, you invoke this reject thing here with the error message or the data you want to reject with, right? So again, we need to do this. We need to say, okay, this is going to be URL. This is what makes it reusable, right? Okay, so now we're making our requests. Now we have this onload, right? And here's our successful data. This is easy enough. Well, we'll go down here because we'll start here. So something bad happened, right? We're just going to reject, bad response code, right? This means the operation worked, but it's not what we want. And down here, this just means, oh, something really bad happened. We're also going to just reject, I don't know, we'll say really bad. Okay? And now here we have our success. we're just going to resolve this. Oh, when we get this far and we have this value here, we know that this asynchronous action and the value is resolved. We're fulfilled. We're done, right? Here we go. That's it. And then here's that API to do that. All we're saying is, hey, go get this JSON. It does all that magic that wraps that activity inside of a little container. And when it's done, it just goes down that list of thens. If there's an error, it'll catch and it'll do this instead.
So what is the new promise object then? Is that built in now?
ES6. Mm-hmm.
Repeat that.
The question was, how do I do a new promise? And Chrome, I don't remember which browsers have it without a polyfill. It's ES6 thing, so it's in Chrome for sure. I don't remember which other ones, but it's you can polyfill it pretty simply. And then on Node, since like 12, I think 0.0.12, it's been in Node. 0.0.12, I don't remember, but it's in Node. So that's kind of cool, right? We're just like, hey, here's this future thing. We're just going to wrap this whole process that's happening, this sub-process, I guess, if you will, inside this little container. And we're going to pass that little container around, and it's going to keep track of its value state, whether it's resolved, rejected, or still pending.
When does it get triggered?
When does what get triggered? I'm sorry?
Promise get called.
So the promise gets passed right here, even before I'm returning a new promise. So the things I attach to it happen next. So right when I do this get JSON, I'm constructing a new promise right then, and I'm returning that new promise. So
when does the async call happen? Does it get executed immediately then?
So this will start off right here on this particular case, right? That kicks off the whole thing, and then that's an event-based asynchronous thing, right? And here are those same callbacks. Hey, when we're successful, do this, and when we're not successful, do that. All we're saying, okay, instead of letting them tell me what to do next, I'm just gonna say, hey, I have a value. You can figure out what to do, or hey, I don't.
To answer your question before, every browser supports promises natively except for IE. That means including Edge supports promises natively. And so for IE is the only one you have to polyfill for. And it's easy to do. And you should not fear the polyfill.
Do you know if this promise API allows for like a deferred way to do it, so you can create a deferred promise and then resolve it? Okay.
Okay, so any more questions about this? Got 5 minutes and all right. So basically here's the answer, right? You just wrap that thing around a promise, return that promise figures out internally when it's ready, things attached to it when it's ready, and when there's an error, they do other things. That's conceptually makes sense, right? So people kind of get tripped up. People don't like this. This is weird to people. Especially if these are just anonymous functions, you have kind of some weird long calls, right? Where it's then, function, this, blah, blah, blah. It can get pretty verbose, right? People don't like that, right? So that brings us to the next thing, right? So here in ES7, you have async await, which is basically you can think of it as just nicer syntax around promises. It still is promises under the hood. This just gets rid of the weird then, the dot then, the dot then, dot then, dot then, dot then kind of thing, right? It gives it a more familiar syntax, okay? And the pros of this, you have more concise code. You don't have this weird thing that people don't like. You really kind of write code almost just like you write synchronous code. There's a couple of keyword differences, and that's about it. And it, again, provides that better syntax. Now, the cons of this is it's ES7. You can polyfill. You can transpile and it will work. And depending on your project, it may be worth all that. Especially if you have a lot of asynchronous stuff, it makes writing your code much easier to reason with. You can't have inner async functions. I'll kind of explain that in a minute. And instead of, before you had dot then, dot then, dot then, dot catch on a promise-based API, this one you actually wrap in try this. If something happens, catch this. And on the node, that's not optimized. They have no plans to optimize try-catch because basically your catcher is your process dying and respawning. So, all right. So this is what this syntax looks like. We define a function. You call it, hey, this function is called request JSON, but we're going to mark this as an asynchronous function, right? And what it's going to do, it's going to try to let response equals await fetch URL, right? And then we're not in a non-blocking way. The rest of your Node app is going on, or your browser app is just going on, blah, blah, blah. But the rest of this process right here waits. It's just waiting for this to resolve. This still returns a promise. But we're just waiting right here for all that stuff to happen. And then when it happens, we move on here. Okay, this is that same thing before. Hey, the response, it wasn't okay. Okay, it wasn't a 200 through 400 response code or whatever, right? So when that happens, we're gonna throw an error. And otherwise, we're gonna return the JSON that came back from that. We're gonna catch around this. This is again just catching. Because we have some activity with no error right here, you always want to try catch, just like you always want to add a dot catch on a promise. Okay, so we're going to catch. So when it detects a rejected promise, it's going to trigger this catch, right? And you're going to console.error the error, and we're going to rethrow it. So we're going to just punt off the handling to the next thing in the list. But at the very least, we're logging out that an error happens, so that if something happens, it's not your errors aren't being swallowed, and you don't know what's going on.
If you're throwing out of the async function, does that mean you have to catch down for infinity? You just have to keep catching and catching?
If you throw from right here, it catches here.
Yeah, but then you're throwing.
So this means that what's end up happening is a rejected promise.
Passing it on to whoever called request JSON. Is that getting an error?
They're getting a promise. They're getting either a resolved or a rejected promise.
E is a promise.
It's a promise wrapped error at this point. So you would just handle it the same way. Yeah, they're literally just promises under the hood. This is just syntax around promises. So this code looks like code you write in like CS 101, right? There's no weird kind of stuff. It's just. Yeah.
Does this mean in the consumer request JSON, they call request JSON and then have to do .then?
There's a couple things, yes. Or you actually would wrap what you want to do around another async function. So here is an async caller to this, right?
That's what I was asking. If you have to wrap the whole thing in this right.
So you can either handle it as a promise or you can handle it in this way, where we say, hey, the thing calling this is also using async await, right? So it's an async function that we're trying to get data from that thing we just defined. If that works, we're going to log it out. If it doesn't work here, we're just going to log the error. So it's not just, yeah, this is the client to that library, right? Questions about that? We're almost out of time. We are out of time. I had one more exercise that I'm kind of glad we didn't get to. But it was basically chaining together a crazy, here's the requirements. So we have these pretend endpoints, API person ID, API group ID. API person ID just returns this object. API group ID returns this object, right? And we would call it like this. And what we'd want, this is kind of contrived, but it resembles sometimes some real life things we have to do, okay? So based on this, what we want to do is we want to create a function that accepts an ID of a person and in return returns an array of other people's names in your group, right? And so that's basically, the pseudocode is find person with this ID, grab that person's group ID, using that group ID, query that group endpoint. This is not right, right? Based on that, you're going to get an array of member IDs. We're going to have to filter ourselves out of that list of member IDs. Then with the remaining array of IDs of members, we're going to create individual requests back to the person endpoint to get their information, and then we're going to map that to just their first names. So if you look at that, there's one asynchronous call here, another one there, and then depending on how many members are in the group, that many minus one asynchronous calls to get that person's data. And so this would be very verbose to do with just events, with just callbacks. Promises makes it a little easier, and then async await would actually, you could do this pretty concisely. So, but we're out of time, sorry. I'll finish it out and I'll put it on Slack, the solution. Okay. So, any other questions about this? No? All right, done.
Thanks, guys. Come to Don't Holes next Wednesday if you're here. Look for the signs.
Good job, man.
Thank you.
Tell your friends about Don't Holes too. Bring all your friends.
Oh, I need to stop recording.